So we said this. To solve circuits, first of all, there was current laws, rules for current, and rules for voltage. For current laws, there was two. First of all, everything flows downhill from positive to negative. Now, that's the opposite of the way the electrons go. Electrons go from negative to positive. But we said it's so much easier to think about going from positive to negative. We're going to do that. So whenever I'm solving a circuit, I'll go find the battery, I'll go find the positive part of the battery, and I'll draw an arrow pointing downhill from there. The second rule was current going in equals current going out at any junction. So all of us, we can do a practice question that I just made up before you guys came here. Here's a circuit. If I was analyzing this, first thing I would do is I would find the battery and I would say, hey, that way is downhill. How many amps are leaving the battery, the chairlift? 9 amps. How many amps went down this way? So how many amps must have gone to the right? 5 amps. Okay? And 5 amps would go through here. 5 amps would go through here. So this is 5 amps. What direction? To the left. And then they meet up. So right here, how many amps do I have? 9. I have 9 amps going right there to the left. Let's try a tougher one. This is just a practice example. Okay? I'm going to give you questions like this on your test, Mohammed. With me here, please. In other words, on your test, I'm going to give you some blank circuit, and I'm going to have blanks and say, fill in the blanks. Okay? They're kind of like puzzles. Again, first strategy is I go find the battery. That way is downhill. Did they tell me the total current anywhere in this circuit? Where? The 8 up there. It wasn't immediately obvious, but that 8 up there does have the total current, because even though our circuit splits the current up, they all join back together right there. So that means right here is 8 amps. 2 amps went that way, 1 amp went that way. How many amps are in the right-hand circuit, the right-hand resistor? Guys, you going to stop talking or am I going to move you? Okay. 5 amps. They join back together. This is downhill. 8 amps right here. This is downhill. 6 amps went that way. How many amps went in the left-hand one? 2 amps. That was the rule for current. Now, the rule for voltage was a little bit different. A little trickier. We said the rule for voltage was you go up, you gain height through the chairlift, and you lose height. So picking up from where we left off, we said that you gain voltage going through the battery. You lose voltage. We said we're treating the resistors like they're ski hills where you lose voltage. And I think we got to, how far? Right to B. Right, example 8. So can you find example 8B? Looks like that. Got to go hunting for it a little bit. That's where we left off. Okay. Can I help you? Okay, next time get a little sooner, right? Okay. To solve a circuit, first thing I want to do is I want to figure out which way is downhill. Where's the battery? Do you see it? Yeah. On the left side. Which way is downhill, upwards or downwards? So let's do a little arrow. That's downhill. Which means the current's going this way. The current splits up right here. Some goes that way, some goes that way. The current goes down over on the right. Tyra, on the bottom, it's going to the left, right? Still flowing downhill. Use your imagination a little bit. They join up there. I've got which way the skiers are going. Okay? What we want to do here is try and fill in every single gap that we can. I always look at current first. Did they tell me the total current in this circuit? Well, yes and no. They didn't tell me, but can I figure it out? Yeah? Riley, how? How many amps went down this hill? How many amps went through this pathway? And do they all join up right there? and that must be total current because there's no other junctions. What is the total current in your head, Riley, my friend? So leaving here, I have 2.5 amps leaving the chairlift, leaving the battery. Remember we said current was like skiers? So in this first resistor, Riley, what's the current? How many amps? Because they can't go anywhere, 2.5 amps. Good. That's the current rule. Okay? Now let's look at the voltages. For the voltages, we look at the height of the chairlift. Lydia, my angel, how high is this battery? How many volts? So what that means is if I go skiing, always downhill, and I end up back at the bottom, I have to have lost 35 volts because this battery is gaining 35 volts. It's giving all the charges extra energy. They have to lose that energy going through the circuit. They have to lose that energy going through the circuit. Sorry, how high did you say it was, Lydia? 35. So if I start skiing downhill like this, how many volts do I lose going through this hill here? 21. What's left? This is why you need your calculators. Sorry? 14. So I have to still lose 14 volts. I can go down this hill and end up at the bottom. How many volts must I lose for that to be the case then in this hill here? I have to have 14 volts. I must lose 14 volts. That resistor, if you put a voltmeter on either side of it, it would measure 14 volts flowing through that light bulb or resistor or appliance, whatever the heck it was. You know what, though? There's another path I could have taken as well. I could have gone, again, leaving the chairlift. How many volts do I lose going through there? Leaving? Am I still going downhill? Was I able to get to the bottom there? So, how many volts in this resistor? I lose 14 volts across that resistor too. This is a little weird. People are like, wait a minute. If I add everything up, I got 21 plus 14 plus 14. That's bigger than the 35. No, that's because the current split up and each charge had to lose that much energy no matter what path they went through. They had energy to get rid of. By the way, we can find something else as well. Can you put a little R right here? From your pink sheet, if you know the resistance and if you know the current, so if you know the voltage and you know the current, how can I find resistance? Yep.
R equals V over I.
Can you do that on your calculators, please? Can you go 21 divided by 2.5? What do you get? 8.4 ohms? I can tell you what resistor that has to be. Oh, not only that, I can tell you how many, if that's a light bulb, how many watts it is. How can I find power? From your pink sheet. Yep. Okay. How can I find power from your pink sheet? Someone said it while I was paused. How can I find power? V times I. So I can tell you how many watts are in this light bulb if I go V, 21, times I, 2.5. This is a, cut it out please, 52.5 watt bulb. Hey, this middle appliance, how many watts is it using? How can I find power? In your head, 14 times 1, no calculator needed. This is a 14 watt appliance. Okay. How many watts in this appliance over on the right-hand side?
14.
How do I calculate power? V times I. What's the voltage there? 14. What's the current there?
1.5.
Okay, so that's going to be 14 times 1.5. This is 21 watts. So, Muhammad, what I want you to realize is in any circuit, at any section of the circuit, if you know two things, you know four things. If you know two of power, voltage, current, and resistance, you can find the other two. And that, to me, is going to be fair game on your test. Your test is probably going to be, I'm thinking, Tuesday next week. No, it's after a long weekend, Thursday next week. Okay, week from Thursday.
Yeah, we'll go Friday.
C. No. C. Okay, let's find all the blanks. Where's the battery, Tyra? You see it? On the left, which way is downhill? Let's quickly walk through the circuit. Let's go, that's downhill. Sherry, that's downhill. I guess it splits up here. That's downhill, that's downhill. That's downhill, that's downhill. You okay with that, kiddo? Okay. Did they tell me total current anywhere? Can I figure out the total current? Do I know how many amps are in this circuit grand total?
No.
Nope. So my strategy is as follows. Evan, you with me? Okay, you focused here? Look for total current first. If not, I go look for the resistor that has two things on it. Is there a resistor that has two pieces of information on it? Which one? The middle one. That's going to be what makes this question fall apart. So first of all, they gave me current, they gave me voltage. What else can I find? I can find the resistance. How can I find R? What's the equation from your pink sheet? Mohammed, in your head, 35 divided by 1. I think you're right. And resistance is in ohms. Okay? Now, how does that help? Mohammed, let's go skiing. Ready? How high is the chairlift? 40. Do I know how much I lose through that hill? Say no. I'm going to go down this way. Do I know how much I lose through that hill? How many? No, amps, not height. What's our equivalent of height in our skiing hill, in our circuit? The voltage, okay? So how high did I start? I don't know how much I lost there. What did I lose here? Did I end up back on the ground? So how high must this hill up here be for that to work? What must I lose in voltage for that to work? Matt, got to be 5 volts. Got to be 5. Got to be 5. Okay? Now, take a look at this circuit. Does the current split up right here and meet up right here? Look at the circuit. Does the current split up and meet up? Yep. So, Priscilla, my angel, how far from here to here in terms of voltage? How many volts do I lose going that way? Volts? 35. So, if I lose 35 volts going this way, and I can shake hands and meet up with the rest of the skiers, the current, how many volts must I lose going this way? This one here has to be 35 volts. We say that these two resistors are in parallel with each other, and parallel resistors will lose the same voltage. How many things do I know over here now? You know what? If I know 2, I know 4. I can certainly tell you the current. Okay, what's the equation, guys? What's the equation for current if I know R and V? V over I? V over R? Okay, what's the current flowing through that resistor? Ah! Nothing? Here we go. Yeah, I got you. Guys awake? You guys awake? I can't read you right now. I don't know whether you're zoning out or following this. What's the current have to be in this side? 7 amps? Okay, got to be 7 amps. Right? Now, look. How many amps right here, Evan? Now, it flows this way and it joins up. How many amps right there? Careful, huh? 8. Hey, now I know total current. How many amps are going through the chairlift? How many amps are going through this resistor? Got to be 8 because they didn't branch off anywhere, right? Oh, what's that resistor? This one you might need a calculator for. How big is that top resistor? V over I. What do you get? Folks, you need to try this. The sooner you try this, the faster this lesson goes, but I'm not doing these in my head. What do you get? No. We're looking here. Where's the 35 coming from? We're looking at this resistor here. What's the voltage drop in that resistor?
0.6.
0.625
Yeah.
ohms.
Thought we cut it off.
Pardon me?
But it's-
Well, 2 or 3 decimal places. Okay. Let's try another one. A couple more, we're done. Okay. A couple more, we're done. D. Okay. Any suggestions? Well, first of all, find the battery. See it?
Yeah.
Downhill is this way. Okay. Did they tell me total current anywhere?
No. Yeah. Five.
Muhammad, you're what? Okay, and that has to be total current because there were no junctions between it and the battery. So the whole current's going through there. If I have total current, this question's going to fall apart. I guarantee it. Let's quickly add our arrows. So that way, that's downhill, that's downhill, that's downhill, that's downhill, that's downhill. Right? Muhammad, what did you say total current was? How many amps? 5. Here's a junction. Okay. Do I know how many amps went this way? Sort of. How can I figure out how many amps went this way? Did they tell me 2 things?
Yeah, they told you everything but the amps.
Well, do I have an equation that has an I by itself? What?
I equals
V over R? And what's the V, Muhammad, my friend, in this resistor here? And what's the R in this resistor right here? Can you do that in your head? 15 over 5. How many amps?
3.
And Adrian, how many amps did you say were there grand total?
5.
So if 3 amps went this way, what can you tell me over here?
2.
Okay? These are like little puzzles. You kind of hopscotch your way along, but we just found something. Cool. Oh, let's keep skiing. How many amps in this 4 ohm resistor down here?
Now we have to do
1.
something with that way.
How many, we're going to come back, but how many amps in this 4 ohm resistor right here? Matt? All 5 again, right? Because the 3 and the 2 join up right here. So again, we have 5 amps. Do I know 2 things in that bottom resistor? Well, then I know 3. What's the voltage in that bottom resistor? What's the equation that has the V by itself?
I times R.
Okay, so it's going to be 5 times 4. Hey, I can do that in my head.
It's 20.
Woohoo! 20 volts. So far, so good. Filling stuff in as we can. Let's start at the chairlift again and see what else we can figure out. Let's go skiing. Jared, my friend, how high is the chairlift? The chairlift. Thank you. Okay, so I have to, if I'm always going downhill, I have to lose 70 volts. Do I know how much I lose in that resistor there? Say no. How many do I lose going through here?
15.
15? How many do I lose going through here?
20.
Could I get back to the ground? Did I arrive back at the bottom of the chairlift?
Yeah.
So, 15 and 20 is what? 35. What did I start with?
70.
I lost 35. What must I lose going through here?
35.
Whatever 70 minus 35 is. Oh, also 35. Is that okay? Do I know 2 things in that resistor? Well, then I know 3. In fact, really, then I know 4. By the way, for all of these, I can ask you for the resistance, or I can ask you for the power, how many watts. In this case, resistance, what's the equation? Has the R by itself?
V over
R equals V over I. So what's the resistance of that top one there? 7 ohms? Are we done, or are there still more blanks to fill in? 2 more blanks. Okay. Can I figure out the voltage here? Let's see.
15?
Muhammad, what?
15 volts went that way.
If this hill is 15 volts high, and I'm saying high even though voltage is it's a measurement of electricity, but if I use the height analogy, it works. You're saying if that's 15 volts high and the rest of the current went this way and they only went down one hill, how many one resistor, how many volts must they lose? Sorry? Nope.
40. Okay.
15 volts again, okay? If you can shake hands and, so Muhammad, here's what we're saying. If you're skiing and you go this way, I go this way. If I go down 15 volts and you meet up with me, you must have gone down the same height hill, right?
But like 15 volts went that way. But that doesn't equal 70.
Yeah, it does. Ready? Ski with me. We're going to go downhill. How high?
70.
Minus 35 is what? Is 35 and 15 and 20. That gets me back to 0, 2. What we're really saying, Muhammad, is this. There's two ski runs. There's that one and there's that one. But both of those, since they end up at the bottom of the chairlift, you have to use up 70 volts in both of them. That's why I draw the arrows to show which way is downhill. Is that okay, kiddo? Yeah. This is Physics 12. You guys are doing good. Do I know two things? What's the third thing? What's R?
V over I.
Yeah, more specific.
7.5.
7.5 ohms. What have I got? 1, 2, 3 more, and we're done. Less whining, more learning. Okay. This one, the line glitched a little bit. This line right here should actually be right there for the battery, but I couldn't get it to fix. So pretend that that line is right there. You ready? Let's figure this out. Did they tell me current anywhere?
No.
No. So William, my friend, the next thing we look for, is there any resistor where they gave me two pieces of information? Sit up, Jared. Right there, they gave me two things. Dev, bottom left? Okay, so what else do I know? If I know that and that, I can find the current. What's the equation? And can you crunch the numbers, please? How do I get V over R in your head? 8 divided by 2?
4.
And here's what's nice about that. Is that not the total current coming from the battery? I think so, because there's no junctions between the battery and this resistor. I just found total current. This question's going to fall apart. Okay. William, we're going to go skiing. You ready? How high is the chairlift? Oh, you know what? I forgot to do which way is downhill. It's my fault. So I think downhill is this way this time, right? That's downhill, that way's downhill, that way's downhill, that way's downhill, that way's downhill. And I guess we split up and we meet up. Ready, William, my friend? Let's go skiing. How high is the chairlift?
8.
No, that's the resistor. Careful, that's not your fault. It's a bad diagram. How high is the chairlift, the battery? 32, okay? And then we're going to lose. What do we lose going through that first hill? What voltage do we lose? You just told me. 8. What's left? 32 take away 8, folks, is what? 24? If I go this way, can I get back down to the bottom, William? So if I lose, start with 32 volts. If I lose 8 volts, what must I lose going down this hill to get back to the bottom? Got to be 24. Hey, I know 2 things. I know 3. What's the current in there?
V over.
Yeah, more specific. What's the current in there? V over R, 24 divided by 10. Really? It's dividing by 10. 2.4? Yes? 24 divided by 10? 2.4? Yes? You okay with that, Sherry? Okay. Why is that nice? William, you pointed this out earlier. What did you say the total current was leaving the chairlift? How many amps went up this way? So how many amps, folks, must have gone to the right? Whatever 4 take away 2.4 is. 1.6, isn't it?
Yeah.
So 1.6 amps in that resistor, 1.6 amps in that resistor. That is nice. Why? Look at this top resistor. How many things do I know now? 2. Well, then I know 3 or 4. I can find the rest. Certainly I can find the resistance. The resistance is V over R. 10 divided by 1.6. Can I do that in my head? 5, 2.5, 0.1, 1.25? 6.25. Yeah, that's better. Ohms. How can I figure out that bottom right resistor? Voltage and then resistance. Any suggestions? And Mohammed, this goes to what you were asking about, okay? So see where the junction is? See where the skiers split up? Right here? Okay? Some go to the right, some go up, but they meet up here, right? If you went down this big hill, Mohammed, how many volts did you lose? How many volts did you lose? Loudly.
20.
So down these 2 hills, how high must they be if I add them together? Got to be 24. Otherwise, there's no way that we could split up and meet up. How high is this second hill over here? So how many volts must this hill be? Do I know 2 things? Then I know 3 or 4. What's the resistance? 14 divided by 1.6, 8.75 ohms. I almost wrote amps. Ohms. So I can't teach you, Kayla, a standard method to solve a circuit. What I can give you is an approach, and it's find total current first if they gave it to you. Otherwise, go look for a resistor where they've told you 2 things, and then start skiing using the current rule and using the voltage rule. Be careful and do the math. Okay? I wrote here, light bulb questions are a good test of student understanding of circuit laws. I'm actually going to do this. I'm going to pause here, and I have for you a bunch of practice. I'm actually giving you some easy and some really, really nasty. I would encourage you, feel free to work with a neighbor on these, but don't just copy off of each other. Explain to each other how you're finding what's what. Let me pass out the sheet. So first of all, can all of you put your name on it? Because I forgot to include a spot for name. My fault. I'm actually giving you some of the same homework, Jared, that I've been giving my Physics 12s. This is going to be, most of these are going to be much tougher than you'll see on the test. What I'm trying to do is make the homework nasty so that when you write the actual test and analyze some circuits, you'll be going, really, that's it? That's my goal, okay? So your homework is all of these, but you're not going to get them all done today. You can whittle away at them. I didn't always go in order of difficulty. I think number 1 is fairly straightforward, I hope. I think number 2 is fairly straightforward, but you'll notice there's a few like number 6. I wrote, hey, this one is nasty. If you get number 6, be impressed. This is one my Physics 12s have some trouble with, okay? Pardon me? Yeah, but remember, anytime you know 2, you know 3 or 4 things, and you keep skiing again. Every time you add something, there's probably something else you can now find. This is good problem solving as well. William, I treat these like little puzzles. I like solving circuits. I'm kind of a nerd that way, but I really like analyzing circuits, okay? When you get towards the end here, there's a lot of these. Some of these may be more difficult than others. I have included the answers, so what does that mean? If you hand this in with only answers, I'm going to give you a 0 and you're going to have to redo it. You've got to show me your work. What do I mean by show me your work? When you find something, write down what you divided by. So if you did I over R, somewhere in the margin, write down what 2 numbers you divided by, and then you put the answer back on the circuit. Do your work right on here. You do not have to recopy these circuits onto a separate piece of paper. I photocopied this deliberately so you can do your work right on here. See how many of these you can get. No, they're actually not too bad. Okay, now you may, Joseph.